Michael.
Guys, there is some settings that we are trying to make. Um, um, just please wait for a few more minutes. We'll start soon. Okay. Hello, hello. Sure, sure. I know, sir. Yeah, thank you. So I hope you can all see my screen. So today we'll be talking about developing engineering clinics project prototypes. Uh, so after 2 3 years of COVID, we started this engineering clinics again, and we hope this is going to help you a lot in bringing out different projects over the course of next 2 or 3 years that of your stay in the university. So, brief introduction to engineering clinics. So this was started from the beginning. It is not present in other branches of VIT. It is present in VIT AP only. Uh, so in the first 2 years, in the first year and the second year of your study, you're going to do for 2 semesters this engineering clinics projects. So in this, in the beginning, we kept for Arduino and Raspberry Pi. Um, but later we thought of expanding, and we thought you can do it on any board because there are many boards available right now in the market. So you can uh, take any of the boards as such, and you can work on it. Right. So I hope everyone knows me. I'm Dr. Ellison from Sense Department, and I will be taking this workshop forward today. Uh, and I mean, like, we'll try to start off very quickly, and we'll try to do some projects. I'll show you how to actually connect a, Arduino and make it work. So, can anyone tell me what is an Arduino board? Do you have any idea of what the Arduino board is? You have the option of unmuting yourself, and you can uh, answer me. Does anyone have an idea what an Arduino board is?
An open source platform where you can use different kinds of hardware and software.
Yes.
Mm,
So as one of you have mentioned, it is a hardware board uh, containing the capability of um, doing some software. So you can run some software on it, and you can program the board in such a way that you can make it do the work that you want it to. So basically, there are different boards available on the market. You have Arduino board, that is obvious. You have Raspberry Pi, that is another kind of board. Uh, you have ESP8266, that is another kind of microcontroller. So there are different things like uh, you have microcontrollers, you have uh, embedded systems. Okay, you have microcomputers itself. So there are many things available right now. So which one should you choose? Which one is the best for you to choose? That depends on uh, the application that you are working on. For example, let us say um, I want to just try to lock and unlock my door. So I'm using a microcontroller, Arduino. Uh, I'm trying to give four keys. Like I'm going to give a keypad interfaced to the Arduino, and if I press one particular key, uh, the door is going to open, or the lock, the safe is going to open. Okay, you have a safe in your house, you want to open it. So you give the right key, it will open the safe. If you give the wrong key too many times, it will lock you out. So in the same way, you can, if you want to perform this, there are certain boards which are very small, which are very minute. You don't require a powerful board like Arduino and Raspberry Pi to perform that. Okay. If you want to perform some high-end task, like you want to collect a lot of data, like maybe uh, 1 GB of data you want to collect, you have deployed some 100 sensors into the field, you're doing some agricultural project, you have deployed 100 sensors, you are collecting data from all those 100 sensors, it's coming out to be 1 GB. So that much amount of data cannot be handled by a Arduino phone. Okay, so you need some higher end uh, microcontroller or an embedded system which can handle that much amount of data and which can push that much amount of data onto the cloud, and or it can push that much data onto any other device that you have connected locally. So there are different types of connections that you can do, but the main point here is whatever the application that you are taking, whatever the problem that you're trying to solve. In the first case, the problem that you are trying to solve is keeping the contents of the safe in a safe manner. Like you should have security. Whatever contents of the safe are there, that should not be accessed by everyone. Only you should be able to access it, and that pin is the requirement. So depending on that problem statement, you have used one small board which is enough to perform that action. Now, in the second case, where you have where your problem statement is collecting data from an entire 1 acre of agricultural field into the device and sending it to the farmer, and the farmer is somewhere else, like remotely, or sending the data onto his smartphone. So when you want to do that, the problem statement changes here. Now the problem statement has to handle lots of data coming from different sensors and pushing it onto the cloud. The cloud will redirect it into his smartphone. So that is a different problem statement. So if you want it, let us take another third example where you want to send a missile to another nation, right? Nowadays, there are lots of war environments that we have seen. Israel, Palestine. Then we have seen Ukraine and Russia. Now, Vietnam and China are also getting up, geared up for it. So, if you think about it, if you think about missiles, that also has an embedded system inside it. So that embedded system is going to direct the missile. It's going to guide the missile to the required destination. So in that case, lot of parameters need to be taken care of, right? The pitch, roll, and yaw of the missile should be taken care of. Okay, at the speed of the missile, the amount of fuel entering into the in a combustion chamber should be maintained. Okay, the elevation, the height, the angle of incidence, all these things should be taken care of. The outside temperature, the temperature inside in the device. So there are several thousands of parameters that we need to take care of when we are talking about a missile. So that is a different application area. So when we talk about developing a project and developing a project prototype, the first thing that you need to do is develop the problem statement. So how can you come about with a problem statement of your own? For example, now you are told in the earlier mail that you have to go and choose a guide, start a project, so and so on. So now how to start a project? How to identify what project you want to do, because you're new to this. So I want to tell you how to actually proceed in finding out the right project for you. So many of you might have gone to the internet. They must have typed projects on Raspberry Pi, projects on Arduino, how to do. So like this, you must have typed on Google and you would have searched for it, right? But when you go deeper, when you want to do a project which is very customized to you, not projects which are already done by someone else and projects which are
Slide
already.
is not moving. The slide is not moving.
Yeah, I'm not moving the slide yet. This is the first slide only. I'm just explaining what is how to do a project and how to proceed with the project. Okay.
Okay.
Yeah. So how to select a project? That's what I'm saying. See, when you go and search on the internet, you're going to find hundreds of projects. So from those projects, if you take, you're just replicating the project. So that is not what anybody wants. Okay. So you can take the idea of the project that are present online, but you have to add some essence of yours to that project, and you have to modify it in a little bit manner such that it becomes yours. Okay, let me tell you an example. Right now, just now I told you one example of securing your Almira or a safe that you have, safe box that you have with the password. So what kind of technique can you use if you want to change this project? See, you have a keypad, enter the 4-digit pin, you will get access to the safe. But if you want to customize it for your own requirement, what else can you do? Did you get my question, guys? You have a safe box, a strong box you have uh, that is guarded by a keypad, and that keypad you will enter for your 4-digit pin, and your safe box will open. Now I want to find out what other kind of additions or some added security you can give to that box to make it more secure. Or if you want to remove that keypad and you want to add some other form of security, some other form of authentication, what kind of authentication you can add?
Face detection, fingerprint sensors.
Sorry?
Face detection,
Yes, face detection, very good.
biometric,
Yes.
We can also use like some cryptographic methods, like we'll be getting some message code OTP code to our phone number.
Okay, very good. Anything else? You can add your fingerprint. You can add voice control.
Iris scan.
Yes, iris scan. Or you can have pattern recognition. So you can have a touch screen there. You can draw some module, not like the patterns that you see on your phone, but a little bit more complex, or maybe some pattern recognition like what is on your smartphone, similar way. So these are different forms of uh, authentication that you can have. So this is just one aspect, what I'm trying to tell you. When you are trying to build a project for one particular application, you will have different aspects in which you can change the project according to your requirement, according to your taste. Okay. So what I'm trying to actually tell you is when you take a project, even if it is from online, uh, try to do something kind of different than what is already there online. Okay, that is going to help you to have critical thinking and creativity. The second thing is when you if you don't want to go about and look online for a project, then look at your daily um, problems that you encounter on everyday basis. Okay, right from the time you get up, you start doing your regular works. You start coming, start coming to the university through bus or from your hostel to university. Uh, and when you're in the university, what are the different things that you encounter? What different problems that you encounter? So like this. Okay. So for example, you're trying to use washroom. Okay. In the fourth floor, you go in AB1 fourth floor. There is a lot of crowd. So the washrooms are full. You go inside and you know and you see every door, every urinal you will see, and you will find out that there is no place. Then you will come down to third floor, that is also filled. Then you'll come down to second floor, that is also filled. So what is the problem here? Finding out a washroom at a difficult time. Okay. So if you have some kind of app where you take data from each and every room that some person is there, do not keep cameras. Okay. You should take some kind of sensor where you can detect the presence of a person, or there will be some kind of, I think in some railways it is already implemented. So if a washroom is vacant or empty, that is being displayed inside the compartment. So in the same way you can do that for your university also. The same thing which you have seen in the Indian railways, you can apply it to your university, but this will be a little bit different, right? So right, like that, if you are trying to encounter some kind of problems in the university, some kind of problems in your home. Okay. Maybe in some neighborhoods there is a lot of theft going on. So where you're living, there is a lot of people who steal different things. So try to put up a security system for your home. Okay, that can be done by this Arduino and Raspberry Pi. Right. So developing project prototypes is not just for the sake of credits, not just for the sake of getting marks. It is finding solutions for your real time on real world problems. Okay. So first thing, very important thing, what you have learned today is finding out the problem. Once the problem is defined, then you can go for developing the project. Just taking one Arduino, taking some resistors, taking some sensors, putting a circuit together will not give you a project. The main thing comes from the idea. Idea comes from problem. So first you define the problem, then you come up with the solution to mitigate the problem, then start working on the project. Okay. So main areas where Arduino is used. So the application areas, now that we understood what is the problem statement, how we can go about it, the main application areas are home automation, public utility automation. So just now I told you for IRCTC, for your home, okay, IoT, drones, security systems, gaming controllers. These are some of the major applications where Arduino is used. It's not used in other different applications because of its limited capabilities. Okay, if you're trying to use it for a simple solution, then you can go and do it. So have you seen an Arduino board? Have you seen it? So it looks something like this. Okay, so here, this black box. So we'll start with on the left hand side. This is your power connector. And this is your data cable connector. So via this data cable connector, you're going to connect the Arduino board to your laptop or your desktop or your computer. Okay, so whenever you're not connecting the board to the laptop, you are going to use this power connection, because when you connect the Arduino board to your laptop via this data connector, the power also will be delivered to the board. You don't need to actually connect the power supply to the board when you are connecting your Arduino to the laptop. But once, you cannot keep the Arduino board connected to the laptop. Okay. So the connection with the laptop and the Arduino board is there only when you are trying to program or burn your program on the Arduino board. Once the Arduino board has received the program, then you can disconnect this connection with your laptop, and then you can give the power connection to the Arduino board, and you can deploy it onto the on-site, whatever you want to, wherever you want to use it. You just give a power connection to the Arduino and you can start using it, because the program is already present in the Arduino board and the program will be executing whenever the power connection is given. Right? So here you have many connectors on the right hand side and on the left hand side. So these are all IO pins. So input output pins. So using these IO pins, you can connect different sensors, you can connect different display devices, you can connect different output devices to send data to the output side or receive data from other devices. So you can have these pins. So these pins are, the first two pins are used for I2C connection. This I2C is a one type of peripheral connection that you can have, and using this you can connect to other devices. Next, this is a ground, and from pin 13 to pin 0, these are all digital IO pins. And pin number A5 to A0. So on the left hand side, you can see yellow color. They are A0 to A5. They are analog pins. So on the right hand side, in green color, you can see digital pins. On the left hand side with yellow, you can see analog pins. So can anyone tell me what is the difference between digital and analog?
Analog has a few mechanical components.
Analog has
A few mechanical components.
mechanical components. Okay, digital has
Digital,
Analog is continuous in time, sir.
yes. Analog is continuous in time. Very good.
Digital is discrete in time, sir.
Yes. So when I say analog, when I say analog, so the wave will be like this. So every point on this wave is going to hold some value. Okay. Any point you take is going to hold some value. It's not like at one point the value will not be there and another point the value will be there. It's not like that. So continuous time means at any time, all real numbers. If time is a real component, real numbers means it is going to have both integers and fractions, right? So time component is continuous. But in the case of digital, the time component is discrete. That means only at regular intervals of time, the value changes, whether it is 0 or 1. In between, you don't have the value. So if you want to draw the diagram for it on an axis, so this is the value at one point. At another point, value is different. At another point, the value is different. At another point, another value. So, okay. So here you have one value and here you have another value, right? So in between these two values, there is no other value present. So in between those two values, there is a void. But in the case of continuous time analog signals, this kind of gap does not exist. Yeah, one person is asking, will the university provide us all these components? I think Deputy Director Sir will send a mail about that. Or maybe he has already sent the mail about that. I'm not sure. But he will clarify these things. I'm not sure about that. So these are the digital pins. So whatever the digital outputs coming from sensors, you can connect on these digital pins from 0 to 13. And if you have an analog sensor, then you can connect that analog sensor to these analog pins A0 to A5. And here we have some VCC and ground pins. Here we can have 5-volt pin, here another 5-volt. Here we have 3.3 volts. Here we have 2 grounds along with this ground on the right hand side. So whatever components you have, whatever connections you want to make, you can make using these pins. And in the program, you are going to activate these pins or read from these pins and do certain operations. So I'll tell you how to do the programming also. So whatever pins that we have, I have described it here in these slides. Let us take one example, because if we take an example and see how we can perform it, then it will be very easy for us to understand. So here we have the Arduino Uno board. Okay. So I have a schematic, a circuit diagram I have. Right. So in the circuit diagram, I have an LED, I have a resistor, and I'm connecting the resistor and the LED in this manner. Okay. So what happens here is LED is going to have 2 terminals. Okay, I hope you know LED is going to have 2 terminals, one on this side, another on this side. Resistor is going to have 2 terminals. Okay, one here and another one here. So now what I'm trying to say is the wire, this is a wire in green. Okay. So this wire is one end is going to be connected to pin 13. Another end will be connected to one end of the resistor. Okay. The other end of the resistor is going to be connected with another wire here. Okay. So this end of the resistor is going to be connected to this end of the LED using another wire. So if I write W, that is a wire. Okay. It is represented in green. So another end of this LED is going to be connected to ground pin on the Arduino Uno. This is another wire. So using this wire connection, if we do the wire connections like this, and if we write a certain program, then we can make this LED blink. Okay, we can make this LED to blink at our request. So let us try to do this. So this is the connection, how we are going to achieve this. So this is the schematic that we draw on paper with a pen. Okay, this is a schematic that we draw on paper. But if you want to make the connections physically, then you need some kind of hardware devices. So here I have the Arduino board. Okay, here I have a breadboard. Here I have an LED, and here I have a resistor, and here I have two wires. Okay, so these are the requirements. And I hope everyone knows how a breadboard works. Should I explain, guys, or do you know this? Should I explain?
Please explain, sir.
Okay. So in the breadboard, you can see all these connector holes that are present. So these are all connector holes. Okay. So into that hole, you can connect a wire, and see, I can connect a wire from here, and I can take it and connect it to 5th pin. Or I can connect here and take it and connect it to 0th pin. So the connections can be done according to our wish. Okay. So there is a certain characteristic of the breadboard that we need to understand here. So all these lines vertically, these 5 holes are there, right? This 30th column, all the 5 holes in that 30th column are one and the same. They are shorted out. So inside there is going to be a metal sheet that is going to short out all these holes. So if you connect a wire here, and if you connect another wire here, that means there is an internal connection between these 2 wires. That means this wire and this wire are shorted out. Okay. So this is the case for all those vertical lines. So line number 30, line number 29, line number 28, and so on to line number 1. Okay, all the F, G, H, I, J, all these holes are shorted out column wise. The 30th column, F, G, H, I, J holes are shorted. For 29th column, F, G, H, I, J columns are shorted. So like this, all these columns are short. This enables us for connecting different components in a nice way, or in an easy way. Okay. Now, Here also we have 5 holes at the bottom side of the breadboard. These holes are also connected, but this 5 holes and this 5 holes are not connected. Okay, there are certain rules for the breadboard. You should definitely remember this. We cannot make you to understand. These are things that we need to remember. Okay. So here we have a short. Here we have a short. So like this, all these columns are shorted. Here we have a short. Like this, all these columns are also shorted. Now coming to the bottom and the topmost panels. So here the shorting is done like this. So all these horizontal holes are shorted. All these horizontal holes are shorted. Okay. These horizontal holes are shorted out altogether. Here also horizontally all the holes are shorted. Here also horizontally all the holes are shorted. But this and this are not shorted. Only that vertical line of holes are shorted. It is not shorted with the bottom horizontal line of holes. Okay, so now with this information in mind, let us now try to do this connection. What connection we need to do? The 13th pin should be connected to one end of the resistor. Other end of the resistor should be connected to one end of the LED. Other end of the LED should be connected to ground. Okay, please remember this connection once more. I'm telling you, 13th pin is connected to one end of the resistor. Other end of the resistor is connected to one end of the LED. Other end of the LED is connected to ground pin of Arduino. So this connections we have to make using the breadboard and LED and resistor to the Arduino board. So see here, 13th pin is connected to one end of the resistor like this. So what is happening here is I'm connecting 13th pin to G hole of third line. And one end of the resistor I'm connecting to H hole of third line. So since vertical lines are shorted out, if I do this kind of connection here with this hole and here I'm connecting the resistor, that means these two are internally connected. Okay, the breadboard helps us to connect these resistor and the wire because of the property of the breadboard where the vertical lines here are shorted out internally. So that makes the connection between the resistor and the wire. The other end of the resistor, you're connecting it to one end of the LED. The other end of the LED, you're connecting it to a wire which takes it and connects it to ground. Okay, did we make the connections as we have seen in the previous case? Here, as in the schematic, did the same connections happen here also? Everyone is clear with this? Anybody is having any doubts? Okay, very good. So once you make that connection, next step what you have to do is go and write the program. So here we have the Blink program with us. Please try to observe this. So when writing a program for Arduino, you have two major functions. The first function is void setup. The second function is void loop. So these two functions mainly we have to use, and these two functions are compulsory. They are compulsorily, they should be present in every program of Arduino. Okay, guys, did you understand? So one function is void setup, another function is void loop. So what happens in void setup function is whatever initialization that you need to do. So every device needs some kind of initial values to start functioning. Yes or no? If you don't give any initial value, then your program is going to start at a indeterminate state. So when you're trying to execute any program, anything you want, you should have some kind of initialization function, some kind of initial values you should have. Only then you can start writing your program. So here what we are doing is, our requirement here is connecting the LED to the 13th pin. And since we are connecting the LED and we are making the LED to glow, if you want to make an LED glow, we have to send voltage to that LED. We have to send voltage to the LED. So the direction of sending the voltage is output. So this is going to be output, not input. So we are not taking in voltage into the Arduino board. We are giving some voltage to the LED from the Arduino board. So that is why we have to, what we have to do, we have to set the mode of the pin as output. So you can see here, there are two arguments that are given to this function, pin mode. So pin mode function is going to set the mode of the pin either as output or input. Okay, so in the void setup function, okay, again I'll explain. First we are talking about void setup function, then we will go to void loop function. So there are two functions here in every C program: void setup function, void loop function. So in the setup function, we have to do different kinds of initializations of your circuit. So here for our case, we have only one LED that is getting connected to the 13th pin. Okay, here 13th pin, and we have to glow the LED. That means we have to send voltage to the LED. Hence, we have to make this 13th pin send voltage to the output side. So we have to send voltage to the output. That means the pin 13 should function as an output pin. So that is why we are setting the mode of that 13th pin as output using the pin mode function. So this pin mode function, when you're calling, you have two arguments here, first argument and second argument. This first argument is the pin number, whether it is 13th pin or 12th pin or 11th pin or 10th pin, 6th pin, whatever it is. The pin number is going to be mentioned as the first argument of the pin mode function. The second argument is the mode of the pin, whether it should act as an input or whether it should act as output. Okay, so here in this case, I have not taken 13, but I have taken LED underscore built-in. This is because the 13th pin is by default connected to an LED which is present on the Arduino board itself. So there is a built-in LED present on the Arduino board. You don't need an external pin actually. So this 13th pin is connected to the LED built-in, and we are setting the 13th pin as output pin. This is the initialization or setup that we are doing in the beginning. Okay, any doubts still here? Anybody? Okay, next we will go to void loop. So this function is a forever loop function. So it is going to execute forever until and unless we remove the power supply to the Arduino board. This is because microcontrollers have this feature. That is because there is no operating system to function in the background, right? So we are creating our own function. We are creating our own operating system by making the loop function run over and again forever. So in this forever loop, we are going to perform our action. So what is the action that we need to perform? What is the action that we need to perform? We are trying to perform blink action. Blink action means for some time the LED should glow, for some time the LED should turn off. Sometime the LED should glow, sometime the LED should turn off. So this is the action of blink. So let us try to emulate that action using software where we write a program to perform the same blink operation. Yes, at the end of the workshop, I will share this document to all of you. No need to worry, okay? So now what we are doing is I'm having a function called as a digital write. If you observe, this is not analog write, this is digital write. And to this digital write, I have two arguments. The first argument is here, the second argument is here. So what is the first argument? It is nothing but the LED built-in pin. The first argument is the pin number. Okay, the second argument is the value that you need to send onto the pin. It can be either 0 or 1. So 0 means low, 1 means high. See, digital and analog both have voltage. So someone in the chat box has asked me a question. Why haven't you connected the wire to analog IO as we are producing voltage? So here one point you have to understand. When I said analog is like this, and if I take it on an axis, x-axis and y-axis. So analog is like this, and digital is like this. So both of them, this is analog, this is digital. Both analog and digital work on voltage. Only difference between analog and digital is for every, if you take on the x-axis at any point of time or at any random point you take, there is going to be a voltage associated with it. But here, if I take any point, there may be a voltage associated with it or there may not be. If I'm taking or sampling my value here, there is no voltage here. But if I take my value, but if I read the value at this point, there is a voltage available. Okay, so what I'm trying to tell in analog is it is continuous. The voltage is continuously applied across all times. At any point of time you take, there is going to be a voltage. But digital, it's not like that. The voltage is applied in intervals. So after, let us say, at 0 seconds, there is no voltage. At second number 1, there is some voltage. At 2 seconds, there is a voltage. And at 3 seconds, there is a voltage. 4 seconds, there is a voltage. 5 seconds, there is a voltage. So like this, with a gap of 1 second each, there is voltage appearing in the digital signal. So in between the first second and the second second, there is 1000 milliseconds, right? 1000 milliseconds are there. In those 1000 milliseconds, there is no voltage. That is the concept of analog and digital. Okay, both analog and digital have voltages, ma. It's not like analog only has voltage, digital does not work on voltage. It's not like that. So here I'm taking the digital pin number 13, which is written as LED built in. So that LED I have set as output. And now it is time to write the values onto the pin. So using the digital write function, I'm writing high, that is logic 1, onto the 13th pin. And after I write that one, I am calling another function, which is delay function of 1000 milliseconds, which is nothing but wait for a second. So this logic 1 on LED on the pin 13 is going to turn the LED on. High is the voltage level. Because of logic 1, the LED is going to turn on. After it turns on, it stays on for a delay of 1 second. After 1 second passes, then it will come down to the third instruction, which is digital write, the same pin number. And here we are giving a 0. We are giving a 0 to the pin. This 0 is going to turn the LED off by making the voltage low. So at here, we are making the LED turn on and we are waiting for 1 second. Then we are making the LED turn off. And then again, we are writing a delay function, which is going to give another second of delay. Okay, after this delay is finished, what is there next? The bracket, the end bracket of void loop. So this is going to take the loop back to the beginning, and these functions are going to be executed again. After execution, again it will go back to the beginning. Again, these functions are going to be executed. Again, it will go back. Again, the functions are executed. Again, it will go back. So this is a forever loop, remember. So every time it comes down, it is going to come back up again, execute these 4 C instructions again, and this is going to happen repeatedly. So when it happens repeatedly, what happens? there is an effect that is created on the LED. That is, the LED will be turned on for 1 second. It will wait. It will stay on. Then it will be turned off for 1 second. It will be turned off. Again, it will go back to the beginning. Again, you're turning on the LED, keeping the LED turned on for 1 second, then turning off the LED, keeping the LED turned off for 1 second. Again, you're going back, turning on the LED, keeping it on for 1 second, turning it off, keeping it off for 1 second. Again, you're going up. So this is happening in a repeated manner. And this repeated action is going to produce the effect of LED blinking. Okay, so any doubts, guys, still here? Anything? Then if you don't have any doubts, then we can go ahead and start making the circuit. I have here with me a breadboard, an Arduino board. I have an LED. I have the connectors. Okay, I have the resistor. All these things I have. I will turn on my video and I'll show you how to make the connections. So once you can understand the concepts which I told you right now, then we can go ahead and make the connections. So please let me know if any doubts are there. So you can please put it in the chat box. If you don't have any doubts, just tell me no doubts like that. Okay, very good. Let me turn on my video. Can everyone see this? So I have here the breadboard with me. Visible, guys? And let me know whether it's visible or not. Yes, okay. Thank you, Chandana. So this is the Arduino board that I was telling you about. So you can see here, this is the USB connector. Okay. So I have here a USB cable. So one end of the USB cable is a USB normal USB type A, and you have this special USB connector here, which gets connected to the connector present on the Arduino board. So you can connect it like this. Okay. So, and the other end of the cable now will go to your laptop. Okay. So using this connection, we are going to connect the Arduino board to your laptop. Okay. So this is very important connection here. And this is the power connector. Okay. Once you stop using your connection with the laptop, you have to start using the power to power this board. Okay. Next is, if you observe, this is your microcontroller. Mega 32G microcontroller. This is going to perform all the operations that we tell them the Arduino to do. And here we have your digital pins. Okay, here we have the analog pins. Here we have the ground and 5 volts. 3.3 volts, all those things which I've shown you on the slide. All these things are there. These are the digital IO pins. These are the analog pins. Okay, and now here I have a breadboard with me, and I'm going to make the connections on this breadboard in the same way how we have done it in the schematic. Okay, so I have here with me an LED. Okay, I have a resistor, right, and I have some connectors like this. So these wires are very easy to find in any kind of electronic shop if you go. So these connectors, if you can see, this connector will be connected into this hole like this. So if you insert this connector into the hole, it gets connected. And the other end of this wire, you can take and connect it to the digital pins of the Arduino like this. Okay, I hope you can see how we have connected one hole, one connection from the breadboard into the Arduino. So these are metal connectors at the end. Okay, if you can just see this, these are metal connectors. So you can just insert them into the connections given. Right. So let us try to make the circuit that was shown in the slide. Again, I don't know. So pin number 30, the pin numbers will be written here. I don't think it is given to you or not, but you can see here pin number 13, 12, 11, 10, 9, 8, 7, so on to 0. Okay, so pin number 13 is somewhere here. Somewhere here, right? So I'm going to connect that pin number 13 to one of the pole of the breadboard. So I'm connecting the pin number 13. And here I'm connecting to one pole of the breadboard. The other end, I have to connect with the resistor. So in the same vertical line, one end of the resistor, I'm connecting here to one end of the same vertical line where you have the same vertical line and connecting the resistor. You should make sure that it is the same line, otherwise the connection will not be made. Okay, the other end of the resistor I am connecting to another line on the vertical line on the breadboard. So now, according to the schematic that we are seeing in the slide, so I'm taking the LED now. So LED, this bent over pin should be connected to this end of the resistor. The other end, I'm going to connect it to another vertical line. So here, the resistor other end and LED's one end should be in the same vertical line. So if you want, you can observe here. The LED's one end will be connected to the other end of the yes, perfect. So now this other end of the LED, finally we have to connect another connector here. Okay, I'm connecting the other end of the LED to the ground pin of the Arduino. So now my connections are done. What is left? I have to take the Arduino, take the cable, connect the Arduino to the cable. So as you can see here, okay, I have connected the Arduino and sorry about that. And the other end, now I'm connecting it to my laptop. So once it is connected, you can see a green LED that is glowing here, which means the board is on. Okay. So now let us disconnect this for now, and let us keep this circuit aside, and let us go to the programming side. I'll stop the video. I'll turn on the video once we start doing the experiment. So now the next step is opening the Arduino project. So this is the Arduino IDE, or integrated development environment, that we have. Okay, and in this we are going to write the program. So already I have written some programs here. So I was just testing out yesterday. Okay. So whatever program that we have seen, it is shown here. So you can see the void setup function, and we can also see the void loop function. So in the void setup, what I did, I have set the mode of the built-in LED as output, and okay, and in the void loop, I have written high value to the pin, and then after some delay, I'm writing a low value. After some delay, again I'm coming up, writing a high value, then given a delay, writing a row value, like this. So this loop is repeating forever. Okay, so now what you have to do is you have to connect your Arduino board again to the laptop, and once you have written the program, whatever program that you want, you write it here. Okay, and you can save it. So I have saved it on my computer with the name blink.c. This is the file that I have saved. Now after saving the program, what you can do is these two buttons you have to press. So the first button, verify, this tick mark button is there, right? Check tick button is there. That is going to verify the program, compile the program basically. So I'm going to click on this. So you can see on the bottom compiling sketch, and there is a bar coming here that is filling up, which tells you that the compilation is happening. And after finishing it, the message done compiling is shown, and you can see that the sketch means your program uses 924 bytes, 2% of the program storage space, maximum is 32,256 bytes. Global variables use 9 bytes of dynamic memory, leaving 2039 bytes for local variables, maximum is 2048. So there are some messages that appear on the screen here. If you can just scroll up and down, you can see those messages, and you have done the compilation process. After you've done the process and you have connected the board to the laptop, the next step is this one. This right arrow is shown, right? This button is going to upload our program to the Arduino board. So before uploading the program, what you have to do is second step. So what is the first step? Verifying the program. So this is going to compile the program, which is the first step. Second step is go to tools. Here you have port. Here we have the port option, and in this port you select, there are some more COM ports, COM7, COM8 and so on. Here I have COM6 with the name Arduino Uno. So select this. If it is not already selected, go to tools, port, and select this Arduino Uno, and go to tools. The board is Arduino Uno. By default, Arduino Uno will be selected. If not, you can select that board. If you have the Arduino Uno board, select the Arduino Uno. If you have some other board, you can select always another Arduino Nano, Arduino Mega, okay, Arduino Mini, Arduino Bluetooth. There are so many. LilyPad is there, Arduino Pro is there. So many different Arduino boards are there. Since here I'm using Arduino Uno, I have selected Arduino Uno in the tools. So these two you have to select, the port and the board you have to select properly. Then you can go for upload. So when you click on upload, this entire program will be sent to the Arduino board via the data cable that you have connected. So I'm clicking on the upload button right now. Okay, I have clicked. So you can see compiling sketch, uploading, and done uploading. So since this is done, let me stop sharing the screen and I'll show you my circuit here. So what is see that ability to program the. So once I program the Arduino board, I can remove power connection. Program will be permanently power system tidy there in the erase. Now I disconnect. As you can see, there is no power to the board. Again, if I connect the same program, the LED blink program will start running. See, how is it possible? This is because the program is already stored into the Arduino and you cannot erase it. If you want to erase it, you have to program another program onto the Arduino. and that is going to erase this blink program and put a fresh program under the Arduino. Okay, you cannot erase the program will always reside on the Arduino until and unless you upload a different program. This program always gets stored in the Arduino board. So here I'll try to show you one more thing. So right now I will change the value to 0.1 second. So what I did here is from 1000 milliseconds, I reduce the time interval to 100 milliseconds. So again, I'm going to verify. Again, I'm going to upload. So since I have uploaded it, now if you see, is really very fast. So this is because I had to reduce the delay between the on and off interval. Yes. So I reduce the delay. So it is going much faster. It is blinking much faster now. Okay. Guys, can you hear me now? Am I audible?
Yes, sir.
Okay. So any doubts still here? Okay. So now let us try to summarize what we have done till now. So we have taken a blink schematic. Okay, then what we did is I have connected the pin number 13 to the resistor. Okay, the other end of the resistor, I have connected it to the LED. The other end of the LED, I have connected to this connector, and this connector is getting connected to the ground. Okay, then after making the connections on the breadboard and the Arduino, Then we'll go to the programming part. We open the Arduino IDE. Okay, can you see the Arduino IDE? So we'll come to the Arduino IDE, then we'll write our program here. After writing the program, we'll verify, then we will upload. So before uploading, you just have to verify whether your board is set to the correct one, your port is set to the correct port or not. Okay, since I have disconnected the Arduino, you can see that the Arduino, COM6 is not showing here. Once I connect it, it will start showing. Just let me try to connect this such that you can see how the port starts to appear. So now I'm making the connection. So you can see COM6 Arduino has appeared on the screen. So once I disconnect it, it will not appear. Okay, so we have to select the correct port. After selecting the board and the port, then you can upload the program onto the Arduino. Once you upload, your program starts executing. Even if you turn off the power, even if you disconnect and reconnect, the program still resides in the Arduino. So Chandrasekhar is asking in the chat box how to dump the written code in Arduino. So I have just now explained, Ma. So you have here, once you write the program, you press this button, verify, you press this button, upload. Since I did not connect it to the Arduino, it's showing me an error. Once you connect it to the Arduino, it will get dumped onto the Arduino board. Okay, so let us see one more program. So this is another program here. So before we go and talk about the program, let me just tell you about this. So this is the LDR program. So LDR is nothing but light dependent resistor module. Can everybody see the screen? I'm showing you a Word document. Can you see the screen?
Yes, sir, it's visible.
Okay. You have the LDR module. You have two jumper wires. I have the 330 ohm resistor. I have an LED. Okay, an Arduino Uno board and a breadboard. These are the components that are required for this experiment. So all these components are pretty much familiar to you all. Only thing is LDR module, I think you have no idea of this. Should I explain this? What is an LDR? Should I explain what is an LDR? Okay. So first read the name. LDR means light dependent resistor. So if I take a normal resistor, its resistance value will be constant throughout its lifetime. Okay, until and unless the resistor burns out, you send a lot of current flowing through the resistor, if the resistor retains its properties and it is not burnt out and if it's not shorted out, the resistor will have the same resistance throughout its life. Okay, but in the case of a light dependent resistor, as the name indicates, the resistor is going to change the resistance value depending on the amount of light falling on the resistor. Okay, so the resistor is photosensitive, you can say. So the photons will be falling on the resistor, right? If a lot of photons are falling on the resistor, the resistance value will be one value. Let us say the resistance value is 100 ohms. Okay, and if not many photons are falling on the resistor, the resistance value is 1000 ohms. So what is happening here? The LDR is having its resistance value, which is depending on the number of photons that are falling on the LDR. So finally, this LDR is a dependent resistor on photons. So from this, I want you to understand what kind of applications we can use this sensor for. This LDR sensor, what kind of real world applications we can use this sensor. See, if you're not able to understand the question, please try to tell me, repeat the question or something like that. Interaction is very much necessary. If I'm just blindly going on and explaining all the concepts, it's not correct. Please try to tell me whether you understood the question or you don't know the answer, whatever it is. Try to type it in the chat box. Yes, very good. Two people, Rishika and JP, both of them have answered in a very good way. One person said we can count the number of notes in a bank using a note counting machine using the LDR setup. And another person, JP, he told we can turn lights on or off in a room depending on whether it is dark or whether it is having sunlight in the outside environment. Very good, very good problems you have defined. These are very simple problems. From here onwards, complex problems will evolve. Okay, simple problems like this, you should be able to understand. Then you can go ahead slowly, you can develop. Okay, at only in one day, you cannot go ahead and start developing big projects like that. You should start small. Okay, slowly your skill will be developed and you can do bigger projects at a later stage. Okay, so this is a very important and very useful thing that they have mentioned. Okay, very good, ma. So this LDR is going to detect the light that is present in the outside environment, and if it is daytime, then turning on the lights in the room does not make sense, right? So normally during the daytime, when you open your curtains,
the sunlight will be coming inside, so you don't require tube lights in your room. So what you can do is you can program the LDR in such a way that when light is falling on the LDR, you can monitor the amount of resistance that the LDR is having, and using that resistance, you can create a program saying that turn off the lights. Okay, slowly, the sun will set and it will become dark outside. So when it becomes dark outside, at that time, the amount of photons hitting the LDR will be less. So that time you can automatically, what you can do, you can turn on the lights. Okay, so the small setup, so the small LDR is capable of doing this particular application. Okay, so I have here my circuit diagram. First, we will talk about the circuit diagram. Then we will go and talk about the code. So I have here with me the LDR module. So this LDR module, if you can see this small orange color one in the left hand side tip, that is the light detecting resistor. And this light detecting resistor is connected to a okay, it is connected to a board. Okay, this entire module is going to work as a board, and depending on the amount of photons hitting the LDR, this board is going to calculate all of that, and it is going to give you an output here on these pins. On the right hand side, you can see 4 pins. One is the VCC pin, that is a power pin. Second one is the ground pin. Third one is the DO pin. Fourth one is the AO pin. So DO means digital output, AO means analog output. So this photosensitive resistor or LDR module will give you different kinds of outputs. One is it can give you output in the form of digital. It can give you output in the form of analog. Okay. So here what I'm doing is I'm not bothering about the analog output. I'm thinking about only the digital output. So VCC, you can see here the green wire VCC is connected to the VCC on the board. The 5 volts on the Arduino board I'm connecting to the VCC pin of the LDR module, green wire. Next one, red wire, I'm connecting ground of the LDR module to the ground of the Arduino board. Okay, then the third one, the digital output I am sending or I am connecting this yellow wire. You can see yellow wire I'm connecting to the 8th pin of the digital IO pins on the Arduino. So you can see here 8th pin I'm connecting to the digital IO, and 9th pin I'm connecting to the resistor. The resistor I'm connecting to the LED. LED I'm connecting it to ground. The blue wires here and here. The 9th pin I'm connecting it to resistor. Resistor I'm connecting it to LED. LED I'm connecting to ground. So this is the circuit that we have. Okay, shall we make the circuit right now? Shall we see how the circuit gets connected? Okay, I have my Arduino here. I have the board also here, the breadboard, and I have my LDR module here. Okay, so what I'm doing is this LDR module, the bottom pins, I am just placing it on the breadboard like this. Okay, I hope you can see this. I have placed the LDR module on the breadboard in this manner. Okay, so now what I'm doing is I'm connecting the VCC. Okay, I'm connecting the VCC to the VCC or 5 volts of the Arduino. Okay, I have made the connection. Next, what is the next step? Ground. So I have the ground pin here. So ground, I'm connecting it to the ground of the Arduino. So since the pins are very small, we have to be very careful while connecting this. Okay, ground I have connected to the ground of Arduino. Now the third pin, that is the digital output, that I have to connect to the 8th pin of the Arduino. So I have connected it to the 8th pin of the Arduino, and the 9th pin, okay, the 9th pin I have to connect to the breadboard, and the other end of that 9th pin should be connected to the resistor like this. So resistor I'm connecting, and other end of the resistor you have to connect it to the LED. Okay, and the other end of the LED you have to connect it to the ground. So this I'm connecting to the ground of the Arduino. So ground is here. I have connected. Okay, the circuit is made. Now let us go to the, let us go. Let me just turn off the video and share the screen. Okay, the circuit diagram is connected. Now let us go to the program. So here in the program, again, we have two functions, void setup and void loop. Okay, in the void setup, what we are doing is first line. In the void setup, I'm setting the mode of the 8th pin as input, and I'm setting the mode of the 9th pin as output. So why I'm setting the mode of 8th pin as input? Because that is where we are receiving the data from the LDR module. So the DO pin of the LDR module, I have connected it to 8th pin. So you can see here, the digital output, the yellow wire, I have connected this yellow wire to the 8th pin of the Arduino. So what is happening here? The photosensitive resistor, the photons are falling on the LDR. This data is getting collected, and appropriate value is generated on the DO line. that value, either it is 0 or 1, whatever it is carried on this yellow line and it is sent to the Arduino board. Since the Arduino board is receiving this value, you have to set that pin as input. So you can write here, since Arduino is receiving the value from the LDR module, the pin 8 is set as input pin or input mode. Okay, so since Arduino is receiving the value from the LDR module, the pin number 8 is set as input. Now coming to the ninth pin. Ninth pin is set as output. If you go back to the schematic, the ninth pin is connected to the resistor, then it is connected to the LED and so on. So here what we are doing is we are giving the ninth pin to and connecting it to an LED. So LED means it's an output device. So it is going to glow. You have to send some value to the LED. So since you have to send some value to the LED, you have to set the LED, set the ninth pin. Since you have to send the value, send a voltage to the ninth pin to either glow the LED or turn it off. We have to set pin 9 as output mode. So we have to set pin number 9 in the output mode. Okay, so these two steps we understood. Third step. So third step is we are calling another function which is serial.begin, and in the brackets I have given 9600. So this is going to connect a serial monitor to the Arduino board. Okay. So this is the setup. So we have set up our 8th pin, 9th pin, and the serial monitor. So serial monitor means you can like whenever you execute a program in C language or in any other language, when you execute the program, you will see some output. Whatever printf statements are there, whatever you want to print on the screen, that screen will show you the print messages, right? So here also, in the same way, we can print some messages on the screen, and that is the serial monitor. Okay. So I have set up my serial monitor also. After that, I close the bracket for the void setup. Now coming to void loop. So here what I'm doing is I'm using a digital read function on pin number 8. So this digital read on pin number 8 is going to read the value from the LDR module, since pin number 8 is what is connected to the LDR module, right? So this value is going to be stored into temp. Whatever value is read from the LDR. So here I can change my whatever value is read on the pin 8, whatever value is read on pin 8, that is coming from LDR module, the value is stored in temp variable. So whatever value means 0 or 1. The value can be either 0 or 1. So whatever value out of those two options is read on pin number 8, and this value is coming from the LDR module, the value is stored in temp variable. Okay, so next step is serial.print intensity. Some message I'm printing on the screen, serial.print. Okay, next I am printing this temporary variable also on the screen. So whatever value is there, that will be printed on the screen here. Next, I give some delay. Then if temp is high, if the value temp is high, that means temp can be either high or low. Okay, 0 or 1 is the value that temp can be, right? 0 means low, 1 means high. So if this temp value is high, and here high means light got blocked, no light is reaching to the LDR, then what we have to do? Turn on the LED. So that is what we have to do, right? Whenever there is no light in the outside environment, whenever the sun is set and it is dark outside, you have to turn on your lights, right? So we are identifying that the value on the temp is high, which means light got blocked, that is no light is reaching the LDR, that means it is dark outside. We are writing a value high on the LED. So that is figuratively we are trying to turn on the lights in our room. Else means if temp value is low, then you turn off the lights in the room by turning off the LED. That symbolizes that you are turning off the lights in the room. Okay, and after that you close the bracket. That means your loop statement will keep on executing always, right? Now that we have this program with us, and I have also connected my Arduino board to COM6, let me just upload the program. So compiling the sketch and uploading it. So you can see done uploading. So since I have finished the upload process, now let me stop sharing the screen and let me turn on my video. So here in the video, you can see the LDR setup is showing like this. And with my finger here, I'm going to block the light that is falling on the LDR. So once the light is blocked, the LED that is present here will glow. This symbolizes that you are turning on the lights in the room whenever the LDR does not detect any photons. So let me just block the LDR with my finger. See, immediately the LED has been turned on. So once I remove the finger and photons start falling on the LDR, the resistance value changes, the DO, the digital output coming into the 8th pin changes. So your condition, the if else condition will be checking the temp value always. Since temp value is high now, since the temp value is low, I think, depending on the condition that we have written. What was the condition? Since temp value is low, then LED is off. Okay, since temp value is low, LED is off. If I keep the hand on the LDR, blocking all the light that is falling on it, the resistance value again changes, making the temp value to go high and the LED to glow. Again, if I remove it, LED will turn off. Again, if I keep it, LED will turn on. So LED will not glow until and unless I keep my hand on the LDR. Little amount of light also, if it is falling on the LDR, the LED will not glow. So you have to block all the light. So if I move my finger a little bit, see little bit of light is falling, LED turned off. See, I'm blocking all the light, LED turned on. Okay, guys, any doubts in this? Please let me know. Any doubts, guys?
No, sir.
Right. Yes, sorry.
So I was asking that if there is a error in the program, how will we come to know about it? So that's my code is wrong somewhere.
If there is an error in the program, let me just show you that also. Okay, I have here something like this. So instead of capital W, I'm writing small w. So that is the error. So I'm compiling the program. So immediately you can see here, what is the message that is coming on the screen? Digital write was not declared in this scope. That means there is something wrong with this function. Remaining all are okay. There is a red line appearing on this line. So wherever the error is there, it will show you the message about that. So you have to understand there is something wrong in this line. Try to revisit all the, whatever function that you have used. Okay, maybe you have missed some bracket, maybe you have missed a semicolon, maybe you have missed a comma here, or in this case, I have put small w instead of capital W. And once I save it and verify again, it will compile nicely. And suppose, let us say in if condition, I have removed one equal to. This will also compile because this is showing equal to equal. So if I put IFF, so it will show you IFF was not declared in the scope. So there is some problem in this statement. So here two F's are there. So just change it. So the Arduino IDE provides you, some kind of a way in which you can identify the errors in your program. Okay. Syntax errors, it can show. Logical errors, you have to do it. That is why programmers, programming is a very difficult task, and it is also a very important one. And that is why companies are paying you lakhs and lakhs of rupees. Okay. So you have to identify the logical programs, you have to write efficient programs. That all depends on the logic that you have in your head. Okay. And that logic, that programming logic, you can develop by continuous practice. Start writing programs from now itself. Start writing programs on different platforms. Start learning different platforms like Python, Java, C, embedded C. This is embedded C, okay? As a matter of fact. And you have many other languages also. One, since most of you are computer science students, you have to learn these programming languages and practice them.
Sir, so we can delete this program if we have to input a new program into the Arduino board?
You cannot delete it. You can always overwrite it. There is no option to delete an already uploaded program on the Arduino.
Okay, sir. So that means we can upload multiple programs on the same board.
No, you can upload only one program.
Okay, sir.
If you want to write a new program, go to File, New. It will open a new sketch. See, already when you open a new sketch, this void setup function and the void loop function automatically will be provided to you. So you just need to write your code here. Whatever you want, you can write your code here. Then save the program, verify, and upload. That's it. So any other doubts? So after this, I have a few points to discuss, important points. That's why I'm just asking you. If any doubts are there, please let me know. Yeah, I will share the recording after the class is done. So the CTS team will give me the recording. They'll share me the recording. Then I can share you the same. And along with the PPT also, I will share all this thing to you. And moreover, I think this entire meeting is recorded and it is streamed onto YouTube. That YouTube link, I think I'll paste it in the chat box. So I think you can access the recording from this YouTube link, I think. Okay, since you don't have any more doubts, I will tell you one important point. So people who are having an affinity towards higher education, people who are trying to go abroad and have their MS completed, okay, or who are trying to, who are trying to write papers, journal papers, okay, research I'm talking about, who are trying to go into the IES or maybe into DRDO, maybe you are trying to go into ISRO, or maybe you are trying to write GATE and getting qualified for MTech in NITs or IITs. So if you are trying to do that, having a conference paper or a conference research paper or a journal research paper in your name will add a lot of benefit to your resume. Okay, the weight that it adds to your resume is very great. Okay, so why is that? Is see, when you say I have done this project, now I showed you one project, right, with LDR module. Until and unless the recruiter tells you to, gives you all these things, gives you an underboard, gives you those jumper wires, gives you an LED, gives you a LDR module, all those things. and he asks you to connect the circuit, dump the program and all, he will not know whether you can actually do the project or not. You will say simply that, sir, in engineering clinics in my first year, I have done this LDR module project. But where is the proof? Actual proof is not there. They will believe you at face value because you're studying in VIT. VIT has something called as engineering clinics. And we are going to tell the recruiters that, okay, every student is going to do engineering clinics projects. But there is no concrete proof to the recruiters that you have actually done the project or you have actually performed the project. But when you talk about research papers like conference papers and journal papers, those papers will be online for anyone to view for your entire life. Nobody can remove that. That is a very, very big concrete proof that you have worked on something. Okay, that is something that your resume when a recruiter looks at your resume and says that this is your paper, he cannot refute that statement. He cannot say, no, you have not written that paper. It's not like that. Nobody can say it's not your paper. Once the paper is published, nobody can delete that. Okay, nobody can say you have not worked on that. That is like an evidence that you have done some work. When you do some engineering clinics project and when you do some other project in your internship or whatever it is, there is no proof of it. But journal papers give you a lot of proof. So where I'm going with this is, you are in your first year, some of you are in your second year. So now you start doing a project under a guide. You try to talk to them after you complete your engineering clinics project. I want to do another project, a research-based project. Here I'll type some things that the university is providing. So in the chat box, you can see RGEMS and VLaunch. These are two kinds of project-based approaches that the university is providing. RGEMS is an internal seed funding project where each faculty will be given 2 lakhs of budget. In those 2 lakhs, you can buy some components, you can do some project. So if you are working under that faculty, whichever faculty you have done your engineering clinics project with, in the next year after completing the engineering clinics project, if you go to the faculty and say, sir, I want to do an RGEMS project under you, extending this engineering clinics project, I want to do another extended project under RGEMS. So he'll be happy to help you. He will do the procedure. He will apply for the RGEMS. RGEMS will come. The 2 lakh funding will come. Using that funding, you can develop a bigger project. So right now in engineering clinics, they are providing you 1,000 rupees only. But 2 lakhs is a very huge amount. You can buy many different components, many costly components. You can do a lot of work. You can buy a cloud server. You can buy bigger modules. You can buy standard sensor equipment. So like this you can do, and you can further your project. This will be helpful to the faculty. Faculty will receive a paper. You will also receive a conference paper or a journal paper. Everyone will be happy. Okay, so this is going to add weight to your resume. Once you finish this in your second year and in your third year, this RGEMS project, if you finish, in your fourth year, you have again 2 projects, capstone project and senior design project. So most of you guys will do the capstone project under the same guide. If you are doing an RGEMS project, the same extension you can do in the capstone very easily. You can finish your capstone project. Finally, in the last semester, you will do internship in some company, or if you don't want to do any internship, or if you don't get any internship, you can do senior design project, STP, in your final semester. This again can be an extension of this engineering clinics project only. So what I want you guys to do is plan out your projects very carefully. Just don't do these projects just for the sake of it, because there is a lot of potential for you to extend. Okay, so once the guide accepts your request on VTop, go and sit with the guide, ask him, on WhatsApp, ping him on WhatsApp, or you go and ask him, whatever you do, contact him, ask him for his free slot, go and sit with the faculty, discuss that you have a plan like this. You are trying to do engineering clinics first, then you want to do RGMs, then you want to go for capstone, then you want to go for SDP. So I'll write this. I'm typing it. The stages what you can do. So you can see here, first is engineering clinics. Next, you can extend the same project into RGMs and V-Launch. That will be for 1 year. Then you can do capstone project in your 4.1 and SDP in your 4.2. The same project can be extended. You can make it bigger. So finally, what happens is you can get a startup out of it. Okay, after your senior design project, you can get a very good product that can be marketed, and you can put this in front of those Shark Tank people also, or you can put this in front of our university. IIC is there, Innovation Incubation Setup. You can put it in front of them. They will help you in your startup. You can start up your own company. Okay, so have a plan like this for your 4 years. So engineering clinics will be the stepping stone for this, for your capstone, for this particular path that you are trying to take. Okay, am I clear, guys? Is it good whatever I shared with you right now? Is it okay?
Excellent, sir.
Yes. Okay. Any doubts in this particular area where RGMs and V-Launch and all capstone? Any doubts you can ask me. Okay, guys. Sorry, I won't take up much of your time. It's already 12:30. I have been talking for 2.5 hours. Your brain must be fried. So I'll take my leave now. Please utilize this opportunity, whatever it is there. See, whatever I told you, it is for Arduino board. You can do the same process for Raspberry Pi. You can do the same process for other boards also, like ESP8266 or maybe TI Texas Instruments. There are some boards available. So like this, the software is available, the boards are available. You can go ahead. You can use the 1,000 rupees that you get for your engineering clinics project. You can buy some components. Mostly, I suggest you to buy Arduino board. For Raspberry Pi, you have to buy Raspberry Pi board. So go ahead and do these things, and try to meet your guides regularly. Try to ask them doubts. Wherever you are stuck, go and clarify them with your guides. Okay, Ma, thank you all. I'll stop the session here.